I'd like to start this video with a little quiz. What sort of thing is this? Well, once we know what it is, we can answer the next question, what can we do with it? Answering those two questions for a lot of folks is actually much harder than it needs to be. If we correctly recognize this as an expression, then we can correctly identify what we can do, which is to simplify it. Right? Now there's some similar sounding words to expression and simplify. That is actually going to be our focus of this video, but let's review what these two words mean, right? An expression is a meaningful collection of, ready for the list, numbers, variables, operations, and or grouping symbols. So I have a couple of variables here, x listed twice, 3, 15, 7, and 5, those are all numbers. I've got some addition, division, and hidden within that division is in fact a grouping symbol. Right? If I want to write this like in an email or something, I would have to say 3x space plus space 15 space 7x, and then to divide I have to just use the slash, the forward slash, 5. I didn't put my plus here. There we go. But this looks like it's just 7x being divided by 5. If I want all three of these terms to be part of my numerator, I have to put parentheses around them. And then I can put the slash. Or if you're fancy, you can use the division symbol, but most word processors don't have that symbol available. Right. So using the division bar avoids having to put these parentheses in, but it's still a grouping symbol the way that it's being used here. Right? And what can I do with this expression in whichever form it is? I can simplify it. Right? Simplify means perform all possible operations. And the second part is less important, but it's still key to knowing what our final answer should look like. And hello, why aren't you typing? And follow standard conventions of mathematical syntax. So let's move these so we can see everything. There we go. Right? So those are two important words for us to know. I feel like being fancy today. All right. So how do we go about performing these operations? Well, 3 times x is the first operation I see. I can't perform that operation. I don't know how many 3's I'm adding together, or I don't know how big x is in order to find out how big 3 of those are. Right? But what I can do is recognize that 3x and 7x both have x's. I can use the associative property, associate this term with this term. And because I don't want to take up too much space. Right? I'm adding these two terms by factoring out the common factor of x, and then performing the addition. 3 plus 7 is 10. But I can't perform this other addition because this is 100 or 10 billion or 10 thirds. I don't know what x is, so I can't add. But instead of just saying this is it, I notice 10 and 15 have a common factor. 5 times 2 is 10, so 5 times 2, x is 10x. 15 is 5 times 3, and what do you know? 5 times something then divided by 5, or better yet, 2x plus 3. Make that 5 times bigger, and then 5 times smaller. I'm basically not doing anything, right? I get 5 over 5, the multiplicative identity. So this scary looking big black expression simplifies out to this relatively harmless blue expression here. Right? That's simplifying. I can't perform the remaining multiplication or addition. I've put the coefficient in front of the variable. This is as good as we can get. So there's simplifying the expression. What we spend a lot of time with, in addition to expressions, is things like 3x plus 15. 3x plus 15 plus 7x over 5. Something like that. Right? And this new symbol makes all the difference. This is no longer an expression. This is still an expression over here on the left. 8 is an expression, right? It's a number. That fits our definition. But these two expressions together linked with an equal sign, that is an equation, right? An equation is a mathematical statement that two expressions have the same value. Now, often our equations are going to have a single value on one side, right? What's the value of this expression? 8. Done. I can change that. Let's go back to blue. Oh, that got really right here. All right, now I've made it unsolvable in this class. Now that I have x in an exponent, we're not going to deal with that. But that can be solved, and that's what we generally do with equations, is solve them. Right? To simplify is a verb, that's what we're doing. To solve is a verb, it's what we're doing. To solve an equation means to find the value. Why are you capital here? Of the variable that makes the expression true. So make sure you have that recorded into your memory here. To solve means to find the value of the variable that makes the expression true. Now I have these s's here because some equations have more than one value that will make the expression, expression, my goodness. Equation. Some equations have more than one value that will make them true. Right? And some equations have more than one variable. So we're looking at ordered pairs or ordered triples or so on. So this is a general definition that will work through all levels of algebra, linear algebra, all of that. Right. So we're not going to start with solving these equations. In fact, let me get rid of this. Okay. There we go. Now this is something we will be able to solve very shortly. But before we get to solving, we need to define one more word, just because we're going to use it all the time. Solution. Right? Solution is a noun as opposed to solve, which is the verb. The solution is that value that makes the statement true. Right? And again, it could be potentially more than one, and it could be potentially more than one variable. And technically, let me change this one too. I go back and forth every semester. I'm going to say equation, because that's what we're talking about, or statement. I'll go with the even more general version of statement, because eventually we're going to look at inequalities, which are not equations, but we're still going to solve them and find their solution in the same way. So let's look at some examples of equations here. Okay. Are these equations? Yes or no? Yes. Right? 3 is an expression. 3 is an expression. 5 is an expression. 2 plus 1 is an expression. I have an equal sign saying this expression is equal to that expression. 2 equations. Is this an equation? Now it's an equation, but when we just have one expression with an equal sign, that does not an equation make. I'm not saying this expression has the same value as this expression, because it doesn't have anything over here. So yes, 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 no. Yes, and we'll leave it at that. Now, equations are statements that can be either true or false. If I look at something like this, we can't say if this is a true statement or a false statement. It's not a statement. It's saying 3 more than something. So 3 years older than me, is that true or false? That's not a thing, right? That's not a statement. If I say my brother is 3 years older than me, now we can decide if this is true or false if we know how old I am and or how old my brother is, right? We need values here to know if it's true or false. We have values here. Is 3 in fact equal to 5? No, it's not. So I'm going to say false. Is 3 in fact the same value as 1 more than 2? Well, 1 more than 2 is 3. 3 has the same value as 3, so that is true. This is not a thing. Here, is this true or false? We don't know yet. Right? It's true if this value is the same as this value. What's the value of the left-hand side? 13. What's the value of the right-hand side? Well, it's x. So if x has a value of 13, then it's true. So the value of my variable that makes this true is 13. So you would say the solution is 13. The value of x, which is my variable for this equation, that's going to make this equation true is 13. If x is 4, then it's false. 13 is not equal to 4. Over here, what's a solution? Well, if x is 0, 0 plus 3 has the same value as 3. So if x equals 0 and y equals 3, then it's true. Let's make this skinnier here. Let's pick a different value. If y is 10, well, what plus 3 equals 10? 7 plus 3 is 10. So if x equals 7 and y equals 10, then it's true. And we could spend all day coming up with pairs of numbers, one of which is 3 more than the other one. Right? If x is 100, y is going to be 103. Right? And next semester, you'll get into listing all of these pairs, including the decimal and fraction ones, and that's going to give you actually a complete line. We're not dealing with two variables right now. So if we're understanding what solution and solve mean, we need a robust understanding that includes multiple variables. But if we're just looking at how do we solve an equation, we'll go a step at a time. So the first method to solve an equation is just guess and check. Now, on the one hand, this is often a really lousy method. Right? If we go back to our original statement, 3x plus 15 plus 7x divided by 5. Right? I'm not just going to say, well, maybe x is 2. Well, maybe x is negative 14. Maybe x is 100.2. Right? I could spend all day making guesses. That's not going to get me anywhere. But for some equations, we can kind of guess and know more intuitively, right? We're not really doing anything. I'm just saying, well, I think x is 2. Right? So let's try that. 13 plus 2. 13 plus 2 is 15. Yeah, I'm not doing the fancy stuff that we're about to explain. I'm just kind of looking at it and saying, yeah, I think I know the answer. Well, we could try this here and say, well, what happens when x is 1? Right? So we're going to evaluate. Let me switch colors here. Let's actually go back to the fancier version. What did I have here? 8 minus 3x plus 2x. 8 minus 3x plus 2x. Okay. So I have 3x plus 15 plus 7x equals 8 minus 3x plus 2x. And we said x had a value of 1. Right? So just like when we're evaluating expressions, we're putting empty parentheses in, then putting in our guess for x, and now I'm just going to do my arithmetic. So 3 times 1 is 3, plus 15, 7 times 1 is 7, 7 plus 3 is 10, 10 plus 15 is 25, 25 divided by 5 is 5, right? I'm going down my paper, simplifying as I go along. Notice, I didn't have to do 3 plus 7 is 10, and then factor out a 5, right? I don't have any variables anymore. I'm adding 3 plus 7 not because those were my x terms, but because that's a pair that adds up nicely to 10. It's easier to do 10 plus 15 to get 25 than to say 18 plus 7 is 25. Too far. All right, so if I show my work a little bit better, 10 plus 15 is 25. 25 over 5 is 5. So this expression, this expression, this expression. All right, over here. 8, 3 times 1 is 3. 2 times 1 is 2. Now I might be tempted to say 3 plus 2 is 5, but I'm not subtracting 5. This 3 is going backwards, the 2 is going forwards, the 8 is going forwards, right? 8 and 2 are going forwards, 10. So I have 10 forwards minus 3. 10 minus 3 is 7. Is this a true statement? No. 5 is not equal to 7. Therefore, this value, 1 in this case, is not a solution. Now, this is not a complete waste of time. There are situations where we really just want this yes or no answer. We're curious, is this particular value that pops into my head going to work? Yes or no? No. Okay, now I have my answer that to the question that I was interested in, does it work? Right? And that's all I care about. So sometimes we don't need to find the solution, we just need to know, is the number I'm interested in a solution, yes or no? Okay, so there's kind of the guess and check method. For more complicated equations, if we are trying to actually find the solution, it's usually not a very efficient approach. But if we're just trying to know, is this number I'm curious about going to work, then we can get the answer without going through the hard work of actually solving it. Right? It just depends on the context and what our goal actually is for that particular equation. But of course, we do want methods that are efficient for truly solving. So let's get into that.